Hey guys, in this video we are going to see how we can do some time series data preprocessing, and we are going to convert a pandas data frame into a set of sequences which are going to be used in later videos for a time series forecasting, classification, and probably anomaly detection. In our case, we are going to convert some multivariate data into time series sequences, and the data is going to basically contain multiple features. So I'm going to show you some of the tricks that I use to convert this kind of data into sequences, which we are going to later on convert into PyTorch datasets. And I'm going to show you how you can train time series data or some time series models that are based on neural networks, of course, using PyTorch Lightning. So stay tuned for the next couple of videos as well. Let's get started, and I'll show you how you can do some time series data preprocessing. So here we have an empty notebook on Google Co-op, and I'm going to start by doing some library installations. I'm going to connect the notebook. We don't really need any GPU, at least for now. And I'm going to install a specific version of TQDM. This will basically allow us to do some progress visualization. And something cool that I've noticed about this Google Co-op instances, at least recently, is that we have those execution basically statistics, and when you're doing some long running task, it tells you basically what is happening. And I'm going to show you this later on when we do these long running tasks. Next, I'm going to continue with a lot of imports actually. And here I'm importing Matplotlib and Seaborn for the visualizations that we are probably not going to make in this video. Next, I'm doing Pandas in NumPy. I'm going to import TQDM for the progress bars, PyTorch Lightning, and we are going to do some min-max scaling. And then I'm basically importing all stuff related to PyTorch. And in this particular example, we are not going to use many of those, but in later videos, I'm just going to use some of those, and I'm not going to basically scroll up and do the imports again. So we'll do basically a bunch of imports right here, and this is executing. So I'm going to also set up the Matplotlib library and the various settings for the color palettes right here and the seaboard styling. And then I'm going to import or call TQDM pandas, which will allow us to basically monkey patch the apply method for pandas, which we are going to use in a couple of minutes. And finally, I'm going to call pl.seed_everything. So this is from PyTorch Lightning, and this will basically go ahead and seed everything, including some multiprocessing steps that you might want to do. And next, I'm going to load the data that we are going to use. And the data itself is going to be from Binance, and it's provided by cryptodatadownload.com. And here we have historical data for different trading pairs. So basically, I'm interested in this BTC to US dollars minute data. And this will basically be a lot of data that we are going to use, and it's going to contain all of those values. And I'm going to show you basically what those are. I've went and used the site to download the zip file, and then I've extracted the data. And from here, we have this Binance BTC USD minute data, and it's about 32 megabytes, I believe. Yeah, 35 or 36 megabytes. So Next, we are going to use Pandas to read the data. And this should be from the file, and we get out complete here. And I'm going to parse the date column. And if we look at the data, you can see that we have the date, the symbol, which is going to be exclusively BTC USDT, and a lot of other values, which are going to be all of those stuff. So we have the opening price, the high price, the low price, the closing price, at least for this minute, because this is minute by minute data. And you can see that the data is probably in reverse order, because this is the 6th minute of the hour, 5th, 4th, etc. So what I'm going to do after loading the data is sort the values by date. And then I'm going to reset the index of the data frame. And right now you can see that the minute by minute data is sorted into the correct order. So this is all good. And let's check the number of rows that we have. We have roughly, about 250,000 rows. So this should be well enough data to do basically anything you want. And let's continue with the pre-processing. One thing that I'm occasionally or very often doing is basically calculating some statistics along the current row and the next row or the previous row. So for example, in this case, we might want to have a look at what is the change from the previous closing price, for example, to the current one. And one really useful method of Pandas is the shift method. And if we shift this by one position, you're going to see that let me just show you the close price right here. So this is the close price, and this is the shifted version by one. So you can clearly see that this maps to the 0th index right here. This maps to the 2nd index right here, etc., etc. And we have just not a number value at the 0th index. So this is basically just shifting the rows by one. And I'm going to use this as a new value or a new column into our data frame. And we are going to call this previous calls, which should be descriptive enough. And if I look at the data right now, you can see that we've added this new column at the end of the data frame. And the first value is not a number, which is going to be a bit of a problem, but we are going to handle this right now. So we want to basically create a new column, which is going to be the closing change price. And here I'm going to apply the progress apply function or a method, which is given to us by the TQDM Pandas library method, sorry. And in here, I'm going to check if the current row is not a number or a none. I'm going to use the numpy method for that. We are going to return a 0. Else, we are going to calculate the difference or the delta between the current close price and the previous close price. And we are going to do this along the first axis, which is going to apply this over the rows, basically. So this will create, again, another column. And as you can see, the progress apply is giving us a nice progress bar. And here is the number of seconds that have passed during this execution. And Google Clock is great enough to give us this execution summary, I guess. So this is a good feature, I believe. And then we are going to have a look at the new data frame. Again, we have this close change price or the delta. And as you can see at the first position or the zeroth index, we have 0 because it was a non-value. And after that, we are just having the amount that the closing price has changed. I believe that this is in probably US dollars, I believe, probably. So next, I'm going to convert all of this into a features data frame that we are going to use for our next couple of models that we are going to have a look at the next couple of videos. And to do this, I'm going to create a rows list. And in this list, I'm going to basically convert all of that data frame into features that we're going to use. So I'm going to iterate over the data frame. And I'm going to do that using TQDM. And I'm going to pass in the number of rows that we have. So it knows how many iterations we are going to do. And I'm going to create a dictionary that is going to contain the data for this row. I'm going to get the day of the week. So to do that, I'm going to access the day of week property. Then I'm going to do the same thing for the day of month. This is just day. Next, we have the week of year. And this can be any features that you want, but I've chosen those. This is a way to basically encode the date. Next, we have the month. And the opening price, the high price, the low price, the close change, which is going to be the newly created feature by us, and then finally the closing price. And I'm going to append this to the rows. And I'm going to convert all of it into a data frame. So here is again TQDM. And one interesting thing about the Google Co-op thing is that it's jumping all around, probably telling us where the current execution point is. I don't know, but it's doing something. All right, so after this is complete, I'm going to just check the shape of it, and then I'm going to have a look at the data frame itself. Now that the feature creation is complete, we have this newly created data frame, and it has all of the same number of rows that we had before. But again, we are just doing some feature engineering, if you will. And in here, we have the new numbers extracted from the original data. Next, we are going to make the split between training data and test data. And in this case, I want to have 90% of the data for training. And I'm going to do that by calculating about 90% of the features, the number of rows that we have. And this will come out to this number. Next, we are going to split the data frame based on this index. We are going to create those two data frames, and I'm going to use the features data frame and get all of the examples before the train. And then I'm going to take all the examples, the train size after this, and I'm going to add 1 just to make sure that no data is leaking between the training and test data. So these are the numbers that we have for training and testing. As you can see, we have the same number of columns or features for each data frame, which is good. And next, we are going to do some transformation of the data. And the transformation that we're going to do is basically a min-max scaler, or scale the data. Scaling the data allows us to probably get faster convergence when training with stochastic gradient descent uh, and when using probably deep neural net models, for example, LSTMs or GRUs or one convs, or maybe if you are kind of on the cutting edge using transformers for time series data. In all of those cases, we are basically training with stochastic gradient descent. So scaling the features and the labels helps us to get a bit of better results, faster convergence, and probably is going to fight against the exploding or vanishing gradient problems that you might have. So one really easy way to do that is to use this SK1 min-max scaler. And in here, I'm going to specify the range -1 to 1. So this will be the range that all of the features are going to be scaled to. And then I want the scaler to fit only the training data. And this is very important because we don't want to leak any of the test data that we have thus far into the scaler. We want to scale the data using only the mean values and the standard deviations of the training data that we have. So the test data is going to be basically just for testing. And we did the same thing here with the split. We first got the first n examples, and then the later on, as the time gets on and on, we are reserving this data for testing. So this is really important because you don't want to leak any data from the test data before evaluating it. Next, I'm going to apply the transformation of the scaler. And I'm going to call the scaler transform method on the training data frame. And I'm going to pass the TrainDF index and the columns. Yeah, this is getting ugly, so I'm going to redo this. So while we're doing all this, basically, if you just pass in the scalar TransformDF, let me actually execute this and I'll show you. If you pass in the scalar transform TrainDF and look at the first row, you see that this is no longer a data frame. And just to preserve the data frame itself, we are going to do the transformation, but we are going to basically create a new data frame that is the same data frame that we had before. But in here, we are going to pass in the index and the columns, and of course, the transformed values, which are going to be this NumPy array. So I'm going to do the same thing for the test data frame. Okay, so run this. And next, let's check what we have into the training data frame now. So basically the same columns, but as you can see, the numbers are very, very different, at least in the price range. let's compare this with the previous prices. We had rather large values, around 10K in US dollars, and now those values are scaled very differently. So this is good. It means that it's doing something at least. And for the final step of the preprocessing, we are going to convert those training and test data frames into sequences. For that purpose, I'm going to write a new function, which we are going to call create sequences. And this function is going to take some input data, which is going to be a Pandas data frame. It's going to contain the target column, the column that we want to predict, and the sequence length. What we are going to do here is basically cut the data into multiple sequences. And I'm going to start by just writing out the function, and then we are going to have a look at an example of how it's going to work. So please stay with me. So the sequences are going to be a list right here, and then we are going to check the number of rows into the input data. Next, we are going to iterate over the data, and we are going to again use TQDM. And I'm going to iterate over the range of data size minus the sequence length. So what will this do is iterate over all of the data except for the last examples, which are going to be the number of sequences that we have. And this is required because otherwise we are not going to have enough data at the end to basically go through the sequences. So the first thing that I'm going to do is get the sequence, and I'm going to use the input data from ith index to I plus sequence length. So this will give us a sequence with the length of the past parameter that we have. And next, I'm going to take the next value, which is going to be the position of the label. And this is going to be I plus sequence length. And this is exclusive, so we are not getting this, but we are getting this -1. So this is basically how the indexing in Python works. So the label position right here is going to be at this position, which is inclusive. I know this might be a bit of hard to get at first, but I hope that when we look at the examples, this all makes sense. Next, I'm going to take the label value itself, and I'm going to take the label position row, and from that, I'm going to take the target column. So this will just give us the row value that we have. And next, I'm going to append the sequence or a tuple of the sequence and the label. Finally, I'm going to return the sequences. And this is pretty much the function that we need. Of course, you might go ahead and try something a bit more advanced, like, for example, sliding windows or maybe another variation of that. This is a really simple implementation in which we are taking every next value and just creating a sequence out of it. So let me run this. And I have a little example right here. And I'm going to create a dummy data frame. And here I want to create a feature which will have the values 1, 2, 3, 4, and 5. And I'll have a column with the name of label 6, 7, 8, 9, 10. Let's look at the data right here. Okay, so we have this very basic data frame, And let's create sequences from this. We'll call the function create sequences. We are going to pass in the label as target variable, and the sequence length is going to be 3, let's say. So this runs, and it's already telling us that it did 2 iterations. So the number of sequences should be 2. And you might think that 1, 2, 3, 2, 3, 4, and 3, 4, 5 are the possible sequences that you can get. But that's not exactly correct, because for the was sequence, you basically don't have a label. So let's check the sequences themselves. And to do that, I'm going to first take the sequence at 0th position. This will give us the sequence. Then I'm going to print out a row, and then I'm going to print out the label. At the 0th position, so the first sequence, the label itself, and this gives us the first 3 rows from the data frame, and then the label is the next, the label from the next row. So this works as expected. And then we have the next example, which is going to be the next sequence. And for this one, we have 2, 3, 4, 2, 3, 4, 7, 8, 9, and the label is 10. So note that we don't have any more labels. So this is why the number of sequences is 2. All right. I hope that all of this makes sense. And next I'm going to create a sequence length constant. I'm going to pass in, for example, 60. I'm going to create a training sequences using the training data frame. And I'm going to pass in the sequence length. I'm going to do the same thing for the test sequences and basically let it run. Now that the preprocessing is complete, it roughly took about 40 seconds combined. Here is the output of that. And let's check, for example, the first sequence. What does it have? Let's first check the label. So this is just a number, and the sequence is going to be basically this. I believe that this is a data frame actually. Yeah, it's a data frame which contains all of the examples that we want. And this should be 59 because it starts from 0. So we have a data frame that contains 60 rows. And this will be a sequence that is created from the large training data frame. This is the shape of it. And to basically check how many sequences that we have the training sequences and the length of the test sequences right here. So this is, let's compare this to the training data frame. So as you can see, let me just copy this. This is the number of examples that we had into the training data frame. And if we do this, you can see that this is exactly so this should be true if we did everything correctly. So this should be exactly the number of the elements that we have into each sequence. So everything kind of checks out. So this is great. And this is pretty much how you can pre-process your time series data. Again, we had multiple features. You can do the same thing basically for a single feature. There is no reason that why this shouldn't work. You might need to do some fiddling, but it should be kind of alright. In the next video, I'm going to show you how you can convert those sequences into PyTorch datasets, and then we are going to train an LSTM or some other model to basically predict the Bitcoin price into the future so we can get rich, all of us. Thanks for watching, guys. I really would love to for you to to give me a like, maybe subscribe to the channel as well, and drop a comment below if you have any questions. Thanks for watching. Bye bye.